Hi Bobcats, this is Miss Lee, and today's video lesson is on writing equations from tables, more specifically writing one-step linear equations. So we're still talking about linear relationships, and one of the things about the linear relationships is that if you're given a table, you should be able to write a one-step equation from the information in the table, and that's what our focus is on this lesson. So make sure as you're watching the video, you're taking good notes. Okay, first step is you need to identify the independent and dependent variables. These are characteristics of linear relationships that we've already discussed. The dependent variable represents y, and the independent variable represents your x. So if you were to graph it, the independent would go on the x-axis, the dependent would go on the y. There's always a relationship between the independent and the dependent because you have to know the independent to get the amount for the dependent. Okay, so once you've identified that independent and dependent, you move on to step 2, which is to identify if it's a multiplicative or additive relationship. If it's multiplicative, the multiplier will be the coefficient to x in the equation. We learned about that when we started talking about algebra. We did our intro to algebra, the different parts of algebraic expressions. That number that you multiply with the variable, that's your coefficient. If it's additive, then the increase or decrease amount will be the constant in the equation. So we talked about constants also. We said constants are those just numbers, that one-time amount that you're adding or you're subtracting. And we talked about the two equation forms that you can write for linear relationships. The first one is y equals kx. It can also be called y equals ax. The a and the x are interchangeable just depending on kind of what you're talking about. And then that's for the multiplicative. Then the second one is y equals x plus b, or sometimes you'll see it as y equals x plus a. Okay, so we're going to take data from tables and we're going to put them in these two equation formats. So let's start with the first one, additive or multiplicative. The easiest thing to do is to look at it and say, okay, I need to turn the x into the y. I need to go from the independent and turn it into a dependent amount. What can I do to 1 to make a 7? Well, I can multiply 1 times 7, right? Well, does that work here? If I multiply 2 times 7, does it give me 14? Sure. So far it looks like we're going to be multiplying by 7. 3 times 7, does that give me 21? It sure does. 4 times 7, does that give me 28? Yes. The last one, it should be a 35. It's a typo. It should be a 35, not a 25. But 5 times 7 does give us 35. So it is a multiplicative relationship. What is the rule? We're multiplying by 7. So we're going to use this multiplicative equation here. The y and the x stay the same. All you're changing is the constant or the coefficient. In this case, it's the k, the coefficient. So it's going to be y equals, and what are we multiplying by? 7. 7x. That is your equation. Y equals 7 times x. Y equals 7x. Okay, let's do the next one. Same thing. We need to turn the x into a y. What are we doing with the 2 to make a 6? Well, we can multiply by 3, right? So use this same rule. You have to check different values in your table to make sure that that rule is the correct rule. This time when I multiply 3 by 3, I get 9 when I should have a 7. So is this going to be a multiplicative relationship? No, it's not. So we have to go back and say, okay, what can we do to the 2 now? What can we add to the 2 to make a 6? And we know it's adding because we're increasing, right? We're getting bigger. We can add a 4. Try the 3. 3 plus 4 is 7, which is what we want. I'm going to come down here to the 5. What is 5 plus 4? 9. So that's our rule. It is an additive, and each time we're adding 4. So this is the equation we would use, and we would replace the constant, the b, with a constant. The x and the y stay in x and y. We don't change their positions. So it's going to be y equals x plus 4. That is your equation. So pause the video and try writing the equations for these two problems. Once you're done, come back and check. Okay, let's take a look at this table. When I saw it, and I saw it going from 14 to 7, getting smaller, I immediately thought of, oh, I can divide by 2. 14 divided by 2 is 7. But when I divided 16 by 2, I didn't get, you get 8, but 8 is not what you want, is it? So it's not going to be a division, which means getting smaller, it's going to have to be a subtraction. So I would subtract 7 from 14 to get a y value of 7. And when I subtract 7 from 16, I do get 9. Now come down here. So I'm going to subtract 7 from 20, and I do get 13. So that is my rule. And remember, subtraction or adding is considered additive relationship, which means we would use the y equals x plus b. Again, the y and the x stay the same, y equals x. And instead of adding a number, we're subtracting. So it would be minus 7. So this is your equation, y equals x minus 7. Okay, how did you do on the next one? What did you get? Well, you might have said, oh, I'm getting smaller, let me subtract 6. But when I subtract 6 from 18, does that give me 6? No, it doesn't give me 6. So it's not subtraction, which means the only other operation that would give you a smaller number is division. So 9 divided by 3 will give us 3. So let's try it with the 18. 18 divided by 3, yep, that gives us 6. And let's try the last one here. 36 divided by 3, does that give us 12? Yes. So that means it is multiplicative, because multiplicative can be multiplying or it can be dividing, and we're going to write it in this format right here. So here we go, the equation y equals, and because this is division, we're going to write it in fraction form. The x is being divided by 3. So y equals x divided by 3. Okay, good job, Bobcats.